The universe is a big place, huge in fact, and rather complicated. Unfortunately, the human brain is relatively tiny and simple, at least in comparison. To help you survive, it has to work hard to make sense of things. It does have some clever tools to help it achieve this. It can turn experiences into symbols, recall sensations, and identify patterns. But most mental tricks take a lot of energy, and so your brain takes shortcuts. For example, it will seek out ideas that confirm what you already suspect. It will find the ideas of people you trust to be more appealing than those of people you don't. It will take your own experience and treat it as evidence. It will blur the lines between what you feel to be the case and what you know to be the case. Most of the time these tricks serve us so well, we're hardly even aware of them. But sometimes they mislead us. The biases which can be so useful can also blind us. And in a complex world of differing opinions, it's hard to know when to think using shortcuts and when to put some effort into using our heads. Thinking doesn't always need to be hard, however. Logic is a useful way to identify ideas that are likely to be helpful. Logic is a way to combine ideas to come to a conclusion. It's like maths, only it can deal with more than numbers. You've probably used it already. Think about the last argument you had. Did it go a little something like this? But everyone else is allowed to go, why can't I? A logical argument would be structured, all people are allowed to go, I am people, therefore I should be allowed to go. Logic is a useful way to combine established ideas to support the acceptance of a new idea. Looking for logic in an argument can help you decide whether you should agree with somebody or wait for more information. Like maths equations, logic has a structure. It looks a bit like 1 plus 2 equals 3. On one side of the equation, we have things we already know or agree upon. On the other side is an answer that's true so long as the numbers on the other side don't change. In logic, an idea is called a premise, which can be put together with other premises in such a way that they lead us to a conclusion. One premise might say magnets attract iron. The other premise might be this object is made from iron. Without seeing it, you can logically say that the magnet will attract this object. But what if you swap around the information? Say magnets attract iron and this object is attracted to magnets. Can you then say that this object is made from iron? Unfortunately not. It still looks like logic, but the conclusion no longer works. Magnets not only attract iron, but other metals as well, such as nickel. This broken logic is called a logical fallacy. This particular example is a formal fallacy, because its form looks similar to logic, but is false. In Latin, and in legal circles, it's called a non sequitur, which means does not follow. It's easy to mistake a logical fallacy for the real deal if you're not careful. People do it all the time, sometimes by accident, and sometimes to fool you. Knowing the structure of a logical argument is important. You wouldn't make the mistake of thinking 3 plus 2 equals 1. Rules are rules after all. Yet breaking the rules of logic can make an answer seem right when it isn't. Logic is built up from ideas called premises. Even if they seem logical, it's important to pay attention to those premises to make sure that they're not made of straw. Strawman arguments are off-topic, oversimplified, exaggerated or subtly twisted versions of your argument that others can easily knock over while still appearing logical. For example, perhaps you're discussing whether vaccinations can help reduce the number of people who fall sick from a particular virus. In response, another person puts forward a counter-argument claiming pharmaceutical companies make large profits by selling vaccines. The focus of the argument is being shifted from the benefits of vaccination to profiteering. It's also easy to think everybody agrees with your starting premises, but misunderstandings or false premises can be slipped in. For example, you can say that the measles make you sick, the measles vaccine contains the measles virus, and therefore the measles vaccine makes you sick. On these simplified facts, this conclusion is logical. But the premises might not be so solid. You need to show that the measles vaccine, which contains the same virus, is present in a form that makes you sick. The measles vaccine actually contains a broken form of the virus that reproduces slowly and doesn't make you sick. This is a subtle but rather significant difference. Even oversimplifying a disagreement down to for and against, true or false, black and white, may be used to mislead you. Remember, there can be more than one solution. Some arguments focus on the person and not what they're saying. A way to keep your focus on the discussion is to think of the sporting phrase, play the ball, not the player. It's hard to listen to people we don't like, and difficult to disagree with those that we trust and admire. But there's a difference between who a person is and what they're saying. For example, you might not like a particular fossil fuel company because of past illegal and unethical behaviour. A smiling representative from the company comes on television and claims their chemical research division has discovered an environmentally friendly, clean form of petrol. It's too easy to be suspicious of their actions. After all, you don't like them. They could be lying to make money. The company's history may imply its actions could warrant closer attention and further discussion, but you can't logically claim that they're wrong based on that argument alone. Linking your dislike with your disbelief is playing the player, not the issue. You can't be an expert on all things, and how you feel about a person can be a tempting first step in deciding if you trust them. But arguments based on who you trust and who you suspect just aren't valid. We turn to experts when we're looking for good advice. However, claiming a conclusion is logically true because an expert made the claim is a poor argument. Climate change is not a concern because experts say so, it's a concern because the facts and the logic indicate that global warming is a sound conclusion. That doesn't mean that we should ignore experts. Instead, we need to ask questions to better understand the facts and the logic that they use. You've watched that coin flip 9 times. Heads, tails, then heads again, then tails, 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 and what's going to come up next? Tails has been having a pretty good run, so it must be another tails. Or are we due for another heads? There are patterns everywhere in the universe, and our brain is very good at recognising them. Perhaps too good. It can readily see patterns that just aren't there. In truth, there is a 50% chance of heads and a 50% chance of tails after every toss. It doesn't matter what came before, and luck doesn't come into it. At all. But it's hard to shake that feeling that there's a pattern in there somewhere, if only we look hard enough. This is called the gambler's fallacy, our assumption that probability changes depending on past results. And this may explain why casinos make so much money. It's all a matter of probability, one of the more complicated forms of logic. In fact, it's so complicated that it was only a few centuries ago that some smart French chaps by the names of Pascal and de Fermat worked out much of the mathematics behind it. Our brains make it difficult for us to see the logic and probability and lead us astray. We're wired to link the things we see as if they're related. For example, seeing a flash of lightning and hearing a boom of thunder makes it seem as if the thunder was caused by the lightning. And there are plenty of reasons to believe that's true. But what if you ate a hot dog and then got sick? Was it the hot dog, or was it something else entirely? Medicine is full of such head-scratching questions. People take pills and feel better. But a lot of logic and probability is needed to determine whether the pills were truly responsible. Just because one thing follows another, even if it happens a few times, does not necessarily mean that they're linked. There could be other factors, or it could simply be coincidence. To know for sure, you have to test the circumstances again and again, looking for those other factors that could disprove the link. This reinforces confidence that your pattern is true. This is what science does. So while our brains see patterns, and this is often very useful, it takes science to prove that these patterns are real. Not acting till you have a good idea of any adverse consequences is called the precautionary principle. This happens every day. Products are tested before they go to market to prove that they're safe, because there's a chance that they're not. But it's difficult to remove all concerns about the risks associated with every single action, let alone those based on the complex series of tests and observations required by science. And here we run into some confusion about how science works. Some say global warming and evolution aren't facts, they're just theories. But there's no just about it. In science, the word theory doesn't mean I reckon. It means a well-tested rule which is based on logic, explains repeated observations, and has been used to make accurate predictions. This makes them incredibly useful and difficult to ignore. Newton's theory of gravitational attraction is a theory. It explains how objects with mass move the way they do. It's a theory so useful that some 300 years after it was first published, it's still used to send objects from Earth to the far reaches of the solar system. Observable or proven facts are only part of science. When we're faced with risks, it's natural to want to wait till there's 100% certainty about it. Unfortunately, that's impossible. The best that can be achieved is that given all our current theories, repeated testing, logic, and the facts, that we're reasonably confident something is safe. And this is where the precautionary principle can be misused. Waiting for more information is useful, but waiting for that unattainable 100% certainty prevents anybody from doing anything. Consider mobile phones and fears that their radiation emissions may cause cancer. If we choose to wait until mobile phones were proven to be 100% safe, or not, we would have no mobile phone technology. Cancer is not something to be taken lightly, and concerns should never be dismissed, but waiting for irrefutable data, which is logically impossible, is a bad way to make decisions. And by doing so, we may lose amazing opportunities or encounter new risks. Asking about risks is sensible, but demanding 100% safety stops technology from evolving. For I should be allowed to go. Logic is a useful way to combine established ideas to support the acceptance of a new idea. Looking for logic in an argument can help you decide whether you should agree with somebody or wait for more information. Like maths and what you know to be the case. Most of the time these tricks serve us so well, we're hardly even aware of them. But sometimes they mislead us. The biases which can be so useful can also blind us. And in a complex world of differing opinions, it's hard to know when to think using shortcuts and when to put some effort into using our heads. Thinking doesn't always need to be hard, however. Logic is a useful The universe is a big place, huge in fact, and rather complicated. Unfortunately, the human brain is relatively tiny and simple, at least in comparison. To help you survive, it has to work hard to make sense of things. It does have some clever tools to help it achieve this. It can turn experiences into symbols, recall sensations, and identify patterns. But most mental tricks take a lot of energy, and so your brain takes shortcuts. For example, it will seek out ideas that confirm what you already suspect. It will find the ideas of people you trust to be more appealing than those of people you don't. It will take your own experience and treat it as evidence. It will blur the lines between what you feel to be the case, a way to identify ideas that are likely to be helpful. Logic is a way to combine ideas to come to a conclusion. It's like maths, only it can deal with more than numbers. You've probably used it already. Think about the last argument you had. Did it go a little something like this? But everyone else is allowed to go, why can't I? A logical argument would be structured, all people are allowed to go, I am people,